The non-access stratum NAS is the highest layer of the control plane over the air interface. The protocol is used between the UE and the core network, the MME. The overall functions of NAS is to support mobility of the UE and to establish and maintain IP connectivity between the UE and the core network. The NAS signal connection is a logical connection between the UE and the MME. Between the UE and the eNode B, the NAS is carried by a signaling radio bearer, and between the eNode B and the MME, it is carried by a S1 signaling connection. The NAS layer consists of two sub-layers: the Evolved Packet System Mobility Management, EMM, and the Evolved Packet System Session Management, ESM. The EMM sublayer will in this document be marked with blue, and the ESM sublayer will be marked with green. The EMM sublayer has to be established before ESM can be used. The EMM sublayer is responsible for authentication and security, attach, paging and tracking area updates, and service requests. The ESM sublayer is responsible for IP address allocation and packet data network connectivity, and bearer handling. The security procedure starts with the UE sending up its IMSI or corresponding ID. From the IMSI, the MME will derive the user operator HSS. The IMSI will be signaled to the HSS. Every subscription has its own security key, K, stored and protected within the HSS. Together with a random number, the K will be inserted into an algorithm. The output from the algorithm will be the integrity key, the ciphering key, the response value, and the authentication network. The integrity key and the ciphering key will be put into another algorithm to form the Key Access Security Management Entity. The K-ASME, the RES, the RAND, and the AUTN will be sent to the MME. MME will put the K-ASME into an algorithm to calculate the key for NAS integrity protection and the key for NAS ciphering. MME will also store the RES value. The K-ASME, the RAND, and the AUTN will be passed on to the eNode B. eNode B will put the K-ASME into an algorithm to calculate the key eNode B. The key eNode B will be put into an algorithm in order to calculate the key for RRC integrity protection, RRC ciphering, and user plane ciphering. Sent over the air interface is now the RAND and AUTN. The UE will use the RAND as an input to an algorithm, together with the key K, which is securely stored on the SIM card. The output will be the integrity key, ciphering key, response value, and authentication network. Before the UE takes any further actions, it will compare the received AUTN with the calculated. if the two parameters match the home network operator is authenticated. From IK and CK, KASME can be calculated, and from this parameter, all the other keys for integrity protection and ciphering usage on the UE side of the air interface can be calculated. KNAS for integrity and KRRC for integrity will be put into integrity algorithms. KNAS for encryption, KRRC for encryption, and K-user plane for encryption will be put into ciphering algorithms. Please note that none of these keys have been transmitted over the air interface. The UE has calculated them by itself, thus providing a high security level. The UE will answer to the MME with a calculated RES value. MME will compare the RES received by the HSS with the RES from the UE. If they match, the UE is authenticated. Please note that the key K stored in HSS and on the SIM card is never sent anywhere, only parameters derived from them. This is what is handled by PDCP. The NAS layer is, as mentioned, responsible for authentication and security. The security is handling both ciphering and integrity protection of the signaling traffic. The security parameters for authentication, ciphering, and integrity protection are tied together in an EPS security context identified by EKSI. These parameters are used as input into the ciphering and integrity protection algorithms. Both the EMM and the ESM sublayers generate plain NAS messages, with a plain NAS message header indicating the type of message. But before the EPS security context can be established, some of the messages between the UE and the MME has to be sent non-security protected. The messages which are sent without ciphering and integrity protection are initial attach request with PON Connectivity request piggybacked, identity request and authentication request. These three messages are sent as part of the attach procedure. Tracking area update after inter-system change is also sent without ciphering and integrity protection if no EPS security context exists. If the radio connection is dropped after initial attach, the NAS signaling connection will also be broken, and the UE will then be in an EMM idle state. But the EPS security context is still valid. So when the NAS signaling connection is re-established with an initial NAS message, these messages can be at least integrity protected. Security mode command is also only integrity protected, since this is the command from the network to the UE during the attach procedure to start the ciphering. When security is activated, it covers only integrity or both ciphering and integrity. Which level of security that is used is indicated in the security protected NAS message header. The network consists of an access part, EU-TRAN, and a core part, Evolved Packet Core, EPC. These parts form Evolved Packet System, EPS. From an end-user point of view, it is the experience quality of service, end-to-end, that is the only relevant quality of service. This end-to-end service can be subdivided into an EPS bearer and an external bearer. The EPS bearer is the bearer that is, from a quality of service perspective, controlled by the mobile operator and defined by specifications developed by 3GPP. The quality of service solution from the external bearer will in many cases be beyond the control of the mobile operator and built on techniques developed by IETF, like diff-serve and MPLS. An EPS bearer is established when the UE connects to a PDN gateway and remains established throughout the lifetime of the PDN connection to provide the UE with always-on IP connectivity to that PDN gateway. That bearer is referred to as the default bearer. Any additional EPS bearer that is established to the same PDN is referred to as a dedicated bearer. The EPS bearer can then be divided into the ERAB, EUTRAN radio access bearer, and the S5, S8 bearer. The radio bearer and the S1 bearer form the ERAB. When establishing the EPS bearer, the EPS quality of service profile will be communicated over the different signaling interfaces. The EPS quality of service profile is defined by 4 parameters. QCI, Quality of Service Class Identifier. The QCI is a scalar parameter pointing to standardized characteristics defined by the operator policy decision. The decision depends on expected traffic load versus dimension capacity parameters, traffic class, traffic handling priority, signaling indication, and source statistics descriptor. QCI is used as a reference to access node-specific parameters that control bearer-level packet forwarding treatment, scheduling weights, admission thresholds, queue management thresholds, link layer protocol configuration, etc. QCI has been pre-configured by the operator at specific nodes, for example, eNode B. ARP, Allocation and Retention Priority, specifies the relative importance between ERABs. The primary purpose of ARP is to decide whether a bearer establishment modification request can be accepted or needs to be rejected in case of resource limitations. In addition, the ARP can be used by the eNode B to decide which bearers to drop during exceptional resource limitations, for example at handover. GBR, Guaranteed Bitrate, the bitrate that can be expected to be provided by a GBR bearer, defined per EPS bearer and only valid for GBR bearers. AMBR, Aggregate Maximum Bitrate, limits the bitrate for all EPS bearers belonging to the same PDN, only valid for non-GBR bearers. The UE uses the uplink packet filter, uplink TFT, to determine the mapping of uplink packets to the radio bearer. Every EPS bearer is associated with an uplink TFT in the UE and a downlink TFT in the PDN gateway. These are the plain NAS messages generated by EMM or ESM. The plain NAS message indicates which procedure is carried out, for example, the tracking area update. This is the security NAS message, indicating if the plain NAS message is security protected or not. The header type field will indicate if the message is integrity protected, or integrity protected and ciphered, or not protected at all. The details for this field is shown here. This field will be indicated for every specific procedure. EMM procedures can be defined in 3 different ways depending on how they can be initiated. EMM common procedures, specific procedures, and connection management procedures. An EMM common procedure can always be initiated if a NAS signaling connection exists. These are the common procedures. Please note that they are all initiated by the network. EMM-specific procedures. The attach procedure initiated by the UE is used to attach the IMSI in the network for services and to establish an EMM context and a default bearer. When a EMM context has been established, the UE Initiate Tracking Area Update procedure can be used for normal or combined or periodic tracking area updates. The detach procedure can be initiated by the UE or the network to detach the IMSI in the network for services and to release the EMM context and all bearers. Note that only one UE-initiated EMM-specific procedure can run at a time. EMM connection management procedures are valid only in S1 mode. S1 mode is when the access network is a EU-TRAN. The service request is initiated by the UE to establish a secure connection to the network and/or to request resource reservation for sending data. The paging procedure is initiated by the network in order to request the establishment of a NAS signaling connection or due to a network failure, prompting the UE to reattach. The transport of the NAS message procedure can be initiated by both the UE and the network. The purpose of this procedure is to attach to a core network. With a successful attach procedure, a context is established for the UE in the MME, and a default bearer is established between the UE and the PDN gateway. The PDN type will specify if an IPv4 or IPv6 address or both should be used. from which PDN gateway the IP address shall be allocated is specified in the access point name. Both these parameters are something that the end user can influence. When a UE attaches to the network, all the procedures shown here might be present if it is an initial attach. One or more procedures may not be present depending on the operator implementation. The attach procedure is an EMM-specific procedure, while the others are EMM common procedures. Let's start with the attach procedure, including 3 messages: attach request, attach accept, and attach complete. This procedure is an EMM specific procedure and will also carry ESM messages piggybacked. The attach request message will be sent without any protection if it is an initial attach. If an EPS security context exists, this message will be integrity protected with old keys. The attach accept and attach complete messages will be sent after security has been established, and therefore they are both ciphered and integrity protected. These are the information elements in an attach request message. If you would like to learn more about the information elements, please click on them and they will take you to a descriptive table. An attach request message will carry the ESM PDN connectivity request message. This is the only ESM message which is not completely security protected. Focus here is to show how the different NAS messages are used together. The initial attach request is shown on the left side. This message is sent without ciphering and integrity protection, since no EPS security context exists. After the plain EMM message, the ESM PDN connectivity request message in green is piggybacked. On the right side, an attach request with established EPS security context is sent by the UE. The reason that an EPS security context already exists when the mobile is powered on is that when the UE is powered off, it will store the old context. If it is then powered on in the same network, the UE can continue with the old context. This attach request will therefore be integrity protected with old keys. So the first message is a security protected NAS message, and in the field called security header, the integrity protection is indicated. After that, the plain EMM and plain ESM messages follow. These are the information elements in the attach accept and attach complete messages. The attach accept message will carry the ESM active default EPS bearer context request message. The attach complete message will carry the ESM active default EPS bearer context accept message. The information in the ESM messages are shown in a later part of this document. Both the attach accept and the attach complete messages are sent after security establishment, so that they are security protected with both ciphering and integrity protection. This procedure is used by the network to request a UE to provide specific identification parameters. It is an EMM common procedure. The first time the network requests the UE to provide an identity is if the UE in the previous message attached request included a GUTI, which is not valid in the MME. So in the first case, the UE answers with its IMSI, International Mobile Subscriber Identity. The second time, the network requests the IMEI from the UE, the International Mobile Equipment Identity. This second request is optional. The information elements in identity request and identity response messages are shown here. Next, the detailed structure of the unciphered identity request and identity response messages will be shown. Primarily, these are used in the attached procedure, shown here framed in red. The NAS messages shown are used for unprotected identity request and identity response. If the identity request procedure is security protected, as in the second case shown in attached procedure, these plain NAS EMM messages will be delivered in a security protected NAS message. The purpose of the EPS authentication and key agreement procedure, called AKA, is to execute mutual authentication of the user and network, and also to agree on security keys. The security key to agree upon is KASME, Key Access Security Management Entity. The EPS AKA procedure is initiated and controlled by the network. In the UE and the network, an EPS security context will be established if the authentication was successful. During the authentication, the ciphering key CK and the integrity key IK are computed. These two keys are used to compute the KASME. The KASME is the root for the EPS integrity protection and ciphering key hierarchy. In the authentication request message, the network will include the RAND, random number, and AUTN, authentication network. The RAND is provided by the network to the UE, so that the UE can compute its own parameters on its side of the air interface. When the UE has calculated the AUTN, it will compare it with the AUTN sent by the operator. If there is a match, the home operator is authenticated. The UE will then answer back with the RES response included in the authentication response message. The RES from the UE will validate the RES from the HSS by the MME. If there is a match, the UE is authenticated. The keys for ciphering and integrity protection are now established. The NAS messages used for authentication request and authentication response. The purpose of the security mode control procedure is to take the EPS security context into use. In other words, to start the signaling security between the UE and MME with negotiated keys and security algorithms. The security mode command message is integrity protected. The UE responds with the security mode complete message, which will be both ciphered and integrity protected. All signaling messages after the MME has received the security mode command message will be ciphered and integrity protected with the selected algorithms. The security mode command is the message that commands the UE to start the ciphering and integrity protection. The message itself is integrity protected, with the key and algorithm negotiated during the authentication procedure. This is indicated with a special security header in the security protected NAS message. The UE answers with security mode complete ciphered and integrity protected, also indicated with a special security header in the security protected NAS message. GUTI, Globally Unique Temporary ID, relocation is an EMM common procedure. The purpose of the procedure is to allocate a GUTI and optionally provide a new TAI list to a UE. The GUTI relocation is performed in a unique procedure or implicitly in attach accept or tracking area update accept. GUTI relocation is a plain NAS message, usually ciphered and integrity protected. EMM information is an EMM common procedure. The purpose of this procedure is to allow the network to provide information to a UE. It is optional for the operator to use, and it is not mandatory for a UE to support this message. During the establishment of EMM, the network may send one or more or no EMM information messages to the UE. There are several types of tracking area updates. Here 2 types are mentioned. With the normal tracking area update procedure, the UE will update the MME with its new position due to a change of tracking area. Using the periodic tracking area update, the UE will periodically indicate that it is still available in the network. The information elements in the tracking area update request message. The tracking area update requests message is an initial NAS message and is therefore protected only with integrity protection. When the UE wants to update its position due to inter-system exchange, no EPS security context exists in the LTE network. In that situation, the UE will send the tracking area update request message without any security protection. The information elements included in Tracking Area Update Accept and Tracking Area Update Complete messages. Service Request. This procedure is used by the UE to change from EMM idle to EMM connected mode, which means to activate the radio and S1 bearers. The reasons for this can be pending DL data or signaling to the UE. The action will be triggered by the network through paging, or pending UL data or signaling. The service request procedure can also be used by UEs in both EMM idle and EMM connected mode to request CS fallback. Note that any indication from lower layers in the UE will indicate that the service request procedure was successful. There is no other response message on the service request. The service request message is a non-standard L3 message. It is also an initial NAS message. When the UE sends a service request, there is no message type defined for a service request, as shown in the picture. Instead, service request is using a specific security header type. Please see the next following figure. Since the service request is an initial NAS message, it will be integrity protected, but in this case with a short message authentication code. The special security header type is 1100 to indicate that this is a service request. There is no message type defined for service request. This message is very short. The total length is only 4 octets. Let's continue with the EPS session management procedure. The purpose of the PDN connectivity procedure is for a UE to request the setup of a default EPS bearer to a PDN. The procedure is used either to establish the first default bearer by including the PDN connectivity request message into the initial attached message, or to establish subsequent default bearers to additional PDNs by sending the message stand alone. The information elements in a PDN connectivity message are called PCO. PCO contains additional optional information about the destination network which the UE is connected to. The PCO is sent transparently between the UE and the PDN gateway. The PCO can, for example, contain the default router address, the DNS server address, and the PCSCF address. Here, the PDN connectivity message delivered together with the attached request message, as well as the standalone PDN connectivity message, are illustrated. The information elements in active default EPS bearer context request and active default EPS bearer context accept messages. Here, the activate default EPS bearer context request and activate default EPS bearer context accept message are illustrated when they are sent as a part of the attached procedure. Here, the activate default EPS bearer context request and activate default EPS bearer context accept message are illustrated when they are sent as standalone messages. When there is a downlink pending data, user data or signaling, the network initiates the procedure by paging the EMM idle UE. Paging is a NAS procedure, but there is no defined NAS message for paging. The reason is that since there will, in almost every case, be more than one eNode B in the tracking area, and each eNode B controls its own radio, the MME can only initiate paging. The EMM layer in the MME will request the lower layers to initiate paging. The protocol used for paging initiation between the MME and eNode Bs is S1AP. From the eNode B over the air interface to the UE, paging will be carried by the protocol RRC. When the EMM idle UE hears the paging, it will establish the radio towards a eNode B and send the service request message. When the lower layers between the UE and eNode B up to the MME have been established, the UE is in EMM connected mode. If the quality of service of the default bearer is enough for the downlink pending data, which is about to be transmitted, it will be activated with the activate default EPS bearer context request. The dedicated EPS bearer context activation procedure is initiated by the network in order to add additional bearers to the already existing default bearer. This is required, for example, when the properties of the default bearer, such as quality of service, do not match the requirements for the new service. When there is uplink pending data, user data or signaling, the EMM idle UE will initiate the procedure by sending a service request message. When the lower layers between the UE and eNode B up to the MME have been established, the UE is in EMM connected mode. If the quality of service for the default bearer is enough for the uplink pending data about to be transmitted, it will be activated with the activate default EPS bearer context request. The dedicated EPS bearer context activation procedure is initiated by the network in order to add additional bearers to the already existing default bearer. This is required, for example, when the properties of the default bearer, such as quality of service, do not match the requirements for the new service. The UE requested bearer resource allocation procedure can be used to ask the network to initiate the dedicated EPS bearer context activation procedures. The information elements in bearer resource allocation request message. The information elements in activate dedicated EPS bearer context request and activate dedicated EPS bearer context accept messages. Here, the activate dedicated EPS bearer context request and activate dedicated EPS bearer context accept message are illustrated.